Hi guys, and welcome to the next video. Today we're going to talk a little bit about the digital inputs and outputs. We're going to say how do we configure them, how they work, where are they used, and where you can find them on the robot. You ready? Let's get started.
5, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Alright, so what are the IOs? So those are inputs and outputs that are coming to or going out from the robot. So basically that's how you communicate with other devices. So either with the PLC or something that's mounted on the robot like robot gripper, weld gun, and so on and so on. The digital inputs and outputs can take only a value of 1 or 0. Where the output is 1, that means output is turned on. When output is 0, the output is turned off. So there is no other intermediate state, like in, for example, analog values, where you can get the voltage, let's say, from 0 to 10 volts, so you can get like 1.5 volt or so on. No, just simple on and off, like a light switch, on and off. So where do we find them? We find them in the I/O menu, and there are many other options over there like group inputs, analog inputs, UOP, SOP, and so on. We'll cover that later on. Today we're going to talk about just the digital inputs and outputs. So when you go to the I/O menu, you can see the inputs and the outputs. But if it's a new robot, there will be nothing in there. Most likely there will be blank, and they are not going to be configured. Or when you're working on the working robot that's already been commissioned and it's being in production, there will be like a names in there. How did they get there and why are they in there? Let's answer that question first. So most likely whoever programmed the robot, or like most of the robots that will be programmed, the IOs are going to be splitted into few ranges. So what is a range? Range is basically the number of the IOs that you're using. So for example, let's take the PLC. In most cases, all of the robots are going to have a range from 1 to 512. And that's your range to communicate with the PLC. Now, that means you can use 512 bits to communicate, and you can use those for whatever you want. Like you can send a start to the robot, you can send some information, maybe position data, I don't know, whatever you want. But how do you say to the PLC that, well, we're going to use this and this to communicate? How does the PLC know and how does the robot know? So there are quite a few ways how we can communicate with the PLC. Some of them are Ethernet IP, the protocols of the communication through Ethernet IP, DeviceNet, or Profinet. So those are just a few. And when you know what type of communication you're using, you can locate the card on your robot. And I've shown you in a video, one of the previous ones, when I opened the robot cabinet and talk a little bit what's where, you can see a Profinet card in there. So you know that you have that card in there, right? And you know that you want to send those outputs through those cards to the PLC or other devices. Great, so we know where the card is located. Now we gotta tell it to the robot because he doesn't know, right? Alright, so when we go to the I/O and we get to the config, you can see that there are a few columns where one is the range, that one that we talked about. So that's like you're saying, hey, I'm going to use this and that many inputs or outputs. The next one is rack. What is a rack? So that's kind of when you go back to old robots, that will make more sense. Right now, but basically by rack right now you will define the device that you're using to communicate with something else. In our case, we're going to talk about the communication with the PLC. Now again, depending on the protocol that you're using, you're going to put a value in there, but basically those values represent the hardware that you're using. So for example, if you're going to use the Ethernet IP protocol or communication, you're going to put 89 in there, because the 89 would tell to the robot, hey, now you're going to connect to the Ethernet IP card. If you're going to put 99, that's going to be a Profinet or DeviceNet. Anyway, the number basically is going to tell to the robot what card you're using. So we can imagine that the robot has like 200 different racks. Like, just imagine that there is like 200 places where you can plug a card. And by saying this number, and those cards are predefined, that means card number 1, which is the Ethernet, has to go to rack number 1. Card number 2 has to go to rack number 2. Card number 3, which is, interbus, has to go to number 3, and so on and so on. So those cards are predefined. So with the rack number, you're basically saying to the robot, hey, right now you're going to communicate with card number 89, Ethernet IP. Then the robot will know, okay, now I'm going to communicate with the cards. Now some of the cards can have one then more input or output, like basically one or more plugs that you can plug the cable in, the wires in, and so on. So there comes the slot. So the slot is going to tell you basically if inside that card, of course again I'm simulating, if inside the card there is more than one plug, and the slot is going to say to which plug you're connecting to. So most cases the slot is going to be 1, but there are some cases when the slot is going to be 2, 3, and so on, depending on the card. Because now you already put the card in, right? You know that we're using the rack number this and this. So you say, okay, this card that's Ethernet IP has to go to rack number 89. I plug it in. Okay, we have the communication through the rack, and now my card has 2 plugs. Okay, which am I going to use? I'm going to use number 1 or number 2. So here comes the slot. If you say number 1, that means you're going to communicate through Ethernet IP card number 89 and slot number 1. And then you have your devices that you will plug to port number 2, right? So that's going to be slot number 2. So that means now you have two things that you will talk to. One is going to be the PLC, other thing is going to be the devices. So you have rack number 89, which is the card, and then slot 1, communication with the PLC, slot 2, communication with the devices. That's just an example, guys. The last thing over there is start number. What is the start number? So basically, this is the number that you wanna start your communication with. So if for any reason, for example, we have the PLC that has 512 bits that you communicate with, right? But for any reason, I don't know, the first 256 you don't want to use, okay? Because, I don't know, because you don't want. Or you want to switch them to be like the first to go to the back, like kind of byte swap. So that's where the start point comes in. So over there, if you put 1, that means if you have the 512 bits, you will start counting from number 1 to 512. And then bit 1 is going to be output 1, bit 2, output 2, and so on and so on. If you change the start number to a different value, that means you will just start counting from that value because it's your start point, right? So if you were using 512 bits and you will put your start number as, I don't know, 200, that means that the output 200 that you will send to the PLC, that the output number 1 that you will send to the PLC is going to be actually output 200. So I hope that you get it. One more time. The start number moves or shifts your start point to the value you put in there. So your output 1 right now is going to be equal to whatever you put in there. Output 2 is going to be equal to whatever you put there plus 1, plus 2, and so on and so on. So you kind of shifted the I/O. So that's why you have the start number. Alright, so that's pretty much it from the introduction part. And right now, let's get to the exercises and see how that works on the robot. Let's do it! Alright guys, welcome to the exercises. So let's get to the I/O menu. So how do we do it? We're going to hit menu, then we're going to go to I/O. Keep in mind, in my case, I/O is on number 5. On your robot, it might be on a different number. And then you're going to go to right, and you're going to select digital and hit enter. And right now we are in our I/O menu. Right now what you can see in here, it says I/O digital out, which means we're looking at the digital outputs. And then as you can see, there is a DO symbol, meaning it's an output. Then you have the number, then you have if that's simulated or not, we'll get to that. Then you have status of your I/O. This is what I said, is it 1 or 0? So is it on or off? The first one is off, the second one is on, for example. And the last one is the comment. So with the arrows, guys, you can scroll down to see all of the other I/Os. If you will hold the shift button and the arrow, you will move by more than one selection. Also, very useful option is if you hit an item in here, you're going to have enter integer and you can go to whatever input or output you want. So I want to go to 512, I will put 512, hit enter, and it's going to take you to the input or output 512. So let's go back to our input number, let's say 50. And because it's an output, you can change the state. You can change it to be on or off. So outputs are sent from the robot. That means you can change the state of it. However, inputs are something that you receive from PLC or devices and you cannot change the state. So let's get to the input menu. We're going to hit here, in, out, and we're going to change to the digital input. And again, it's the same. You have the indication that that's input number 1. It's not simulated. It has the status of on. And if you want to change the state of it, on or off, you cannot, because it says that you cannot set unsimulated input port. This is because this is the signal that the robot is receiving. Alright, let's go back to our outputs. So how do we name the outputs? So you're going to hit next, and in here you have a detail button. You're going to hit detail, and in here you're going to hit enter, and you can change the name to whatever you want. Let's name it out1. You hit enter, you go back, and this is your output number 1. Then there are 2 more options, as you can see in here. Those are used to segregate the inputs based on the number or based on the comment. So let's go to input number 1, output, I'm sorry. When you hit this button, the robot is going to sort all of your inputs based on the name. So if for any reason you need to sort it by name, you'll get it from A all the way to Z. But most of the cases, sometimes when you go to that menu and you see that the numbers are pretty looking strange, just hit numbers in here and you'll get back to the regular 1 to whatever inputs you have. You have also a help menu in here. So when you hit the help menu, you're going to see a help window where you can find a lot of information regarding what's what inside the I/O screen. Okay? So now, before we get to config, let's switch back to our inputs. And I wanted to tell you a little bit more about simulating. So because the inputs you're getting is something that you can only receive, you cannot send it, that means you cannot change the state of it. But there is a way in FANUC to do it, and that's called simulating. So you're going to simulate that input is on or off. So you can run the robot sequence without using the PLC or without getting the feedback from the devices. How do we do that? So when you are in the digital input screen, you can see we have a simulate button in here. and unsimulate. So for the inputs, it's the same. If we get to the simulation column, we can simulate it. So we can simulate a state of the input and output. Why do you want to simulate the state of a digital output? Because maybe there is some data that you don't want to send to PLC. So you can simulate it, and whenever it's simulated, it will never change the state as long as you don't say so. Okay, going back to inputs. So let's simulate input number 11. So we're going to go to input number 11. We're going to go to simulation column. We're going to hit the simulate button. Right now we're going to move one arrow right, and we can turn it on or off. So that means right now you can simulate the digital input. That means that input is not really coming to the robot, but you are telling the robot that yeah, the input is there, so you can run the program. So I will show you later on when we go to the logic commands, like wait command. You can wait for an input, but if the PLC is not working right now, you can simulate it, and then you just go past this line because you have this input simulated. Alright, how do you unsimulate the input? So you're going to back to the simulation column, and you're going to hit unsim. And that will just automatically take out the simulation. If the output was on, it's going to automatically turn it to the state that it is right now. What happens when you simulate many inputs and you don't remember which one were simulated? There is an option to unsim all of the inputs and outputs, so basically all of the signals by one click, and you're going to do that by hitting function, next, and unsim all I/O. And as you can see, all of the I/O got back to the regular state. And the simulation works the same on the inputs, so you can simulate an outputs, you can simulate an output and leave it to off or on. That means that this output is always going to stay on or off, regardless if the robot will set it to on or off. Alright? So that's pretty much it from the simulation, from the simulating, from the I/O, and now let's go to the config. So the thing that I was talking about in the introduction, how do we actually config the input and output so the robot can talk to the PLC or to the devices. So there is a button here called config. It doesn't matter if you're on the input or the output side, just hit config, and it will take you to the configuration menu. And as you can see, we are right now in the digital output configuration menu. When you hit in out here, you're going to be in the digital in configuration menu. When you want to go back to the input or outputs, you can simply click the monitor and it's going to take you back. Okay, let's go to the config. Let's go to our outputs, and let's talk a little bit more about it. So remember guys, as I told you, there are 4 important things while setting up the robot configuration. First is the range. So those is the amount of the input or outputs you're going to use to communicate with something. The second thing is the rack. So this is the actual device. As you can see, in here we're using rack 89, and device name is shown as Ethernet IP because 89 is assigned to the Ethernet port. Then the next thing, remember, like I told you, is the slot. So like, where are you actually connected to? And the last thing is the start. So like I said, it's like, do you want to offset your bits or you don't want to offset? If you don't want to offset, you will always start at 1. If you want to offset your bits, you're going to start at more than 1. So let's add a little bit more signals in here. So let's say I want to do that many signals, and as soon as you change it, it's going to say that the assignment is invalid because there is nothing in the rack, nothing in the slot, nothing in the start. So right now we're adding a new assignment. So I'm going to assign the bits from 513 to 600. I'm going to say that I'm going to use also an Ethernet port. I'm going to use slot number 2, let's say. And we're going to use start bit number 1. And as you can see right now, the state change to pending. So there are three states, actually four states in the status. One is unassigned. That means that those inputs, this range is not being used. It's not assigned to anything. It's free for you to use. So you can pick any of those IOs and assign it to something. The second was the invalid state. And that state was basically saying that something is not okay. Something in your configuration is wrong. And the next one is pending, the one that you can see right now. That means that you've made a change and the robot is waiting for the cycle power, as you can see in here, to apply those changes. And the last thing is the active. That means that those inputs or outputs are already assigned and they are ready to go. All right, so let's cycle power. We're going to go function, next, cycle power. Are we sure do you want a cycle power? Of course we do. So we click yes. Now we wait for the robot to boot up and we're going to see if our assignment is okay, or maybe it's not. And you're going to assign the inputs in exactly the same way. All right, we have no errors in here, guys. Good news. Let's go to our inputs. There you go. That's our new assignment. Now, there is one more thing that you should know. That's monitor. So if we click in here and click the monitor, we're going to be taken to input number 1. Now, when we go back to config, we select this one and we click monitor, we're going to be taken to output number 513. So if there is a specific range you want to go to, that's the fastest way. You can see what device is it. You're going to hit monitor, bam, you'll be taken to that device. Now you're going to ask me what are those asterisks. So those asterisk symbols means that those outputs or inputs are not used. So in the config menu, you can see that number 633 is not being used, is not assigned to anything. That's why they have asterisks in. The same apply for the inputs. So when we go to something that's not being used, we go to monitor, you can see that this input is not being used. And the same in here. So that's how you assign the inputs. How would the robot look like when you get it out of the factory? So let me show you. There is a delete button that's going to delete your assignment. So when you hit the delete, it will ask you, are you sure you want to clear the assignment? Yes, we do. And the assignment is gone. As you can see, those outputs were automatically accumulated to the unassigned outputs and they will sum up. If I'm going to delete this one, we're going to have a blank space because there is something assigned between 512 and 601. But if we get rid of this one, everything will be in one assignment. Okay, so most likely that's how the robot will look like when you get it out of the factory. So how do you set it up? Let's say we're using a Profinet to communicate with the devices. So Profinet uses rack number 99 and rack number 100. Rack number 99 is used to communicate with PLC, rack number 100 is used to communicate with the devices. So we're going to use 512 outputs to communicate with the PLC. So we're going to use rack number 99, slot number 1. We don't want to use offset number 1. This is going to be our PLC communication. Then let's say we're going to use outputs from 1024 to let's say 1000, I don't know, 110. And we're going to use those outputs to communicate with our gripper or whatever tool we have. So we're going to use rack number 100, slot number 1. We're going to start from the first bit. So right now, guys, what we've done, we've assigned a portion of the outputs to the PLC in here because we're using rack number 99, and we assign a portion of our inputs to the Profinet devices. The Profinet devices are in rack 100. So we're going to use this as our outputs to communicate with devices, this with the PLC. Let's cycle power. to make sure everything works fine. And basically that's how you're going to create your assignments. Of course, there's a little bit more behind it because you need to assign signals to it. You need to create a Profinet project if that's a Profinet, but that's what you should do on the robot side. Okay, let's go to our inputs. Config. As you can see, we have our PLC inputs, we have our devices. When we monitor, you can see we'll start from this one. Other ones are asterisks because they are not being used. When we go to our digital outputs and we go to 512, it's going to be our last one, and then we have all of the asterisks. Those names will not be here when you get the robot new. They are just being here because there was something already assigned to them. Alright guys, let me just show you how do you toggle inputs and outputs inside the robot program so we can see what's going on. So when we go to our program, let's create one very fast. Let's call it program 1, 2, 3, 4. Okay, so how do you toggle an input inside the program? You're going to go to Insert, IO, the second option, hit enter, and we want to turn on an output. So we're going to do DO, and let's turn on output. Let's see, maybe 82. So we're going to do 82. We hit enter, and then we have a few options. We can turn it on, we can turn it off, we can pulse it. That means that we can send it out just for, let's say, 2 seconds. We can also use a register value, or we can use some logic with it. So let's just turn it on. Let me add a few lines here so you know that we are actually running the code. Okay, so when we are going to run the code, we're going to turn on that input. All right, and that's how you send an input out to devices or out to the PLC.
All right, guys, and that's all for today. I hope you enjoyed the video. Don't forget to like, subscribe, leave your comments down below, and like always, see you in the next video. Bye bye.